IWM Duxford for the Battle of Britain Air Show. This is going to be a demonstration of Concorde's nose droop. This Concorde belongs to Duxford Aviation Society, a charity based here at Duxford, and we own all the airlines here, which I know some of you have been looking at already today. This Concorde is a pre-production Concorde. There were two of them. This is the British government one, and there's a French government one. And it did most of the test flying in the early part of the 1970s. It's been here, retired for nearly 50 years, but it still looks like the day it was made almost. What we're going to do is we're going to go to New York from London and show you the various stages of the nose droop. This Concorde is the actual one that developed the nose droop. Our pilots today are Simon and Clive, and somewhere on board is Maxine, who won the raffle. It is very compact on board, so they're probably getting really hot there now. So, we're going to fly from Heathrow to JFK, New York. The pilots will have been on board for about an hour, 100 passengers, 90 tons of fuel, and they're ready to start. Concorde couldn't start itself, it had to be started by a ground start machine. So when they're ready to start, they're going to put the navigation lights on the wingtips and the anti-collision lights. You might be able to see them, some of you, where the fuselage and wing will join. Once they've got two engines started, they can push back and get the other two engines started itself, and they're ready to taxi. The only problem is they can't see the taxi line because of that big nose. So to see the taxi line, the first thing they're going to do is lower the heat shield visor. So now you can see the actual cockpit window, but the pilots still can't see the yellow line to taxi out to the runway. So to taxi out, the nose lowers to 5 degrees. So like that, they can taxi out towards the runway. As they're approaching the runway, to go on the runway, they need to have their lights on, so they can put their landing lights on and the taxi lights. Taxi lights are those on the side of the cockpit. The landing lights are recessed into the fuselage, and some of you will be able to see them motoring down, and they fully illuminate when they're down. So like that, they're going to go out onto the runway. With virtually every other airliner, you calculate the throttle settings depending on weight, the weather and so on. Concorde doesn't mess about. All four throttles go to full power, and away she goes. At about 70 miles an hour, the afterburners or reheat kicks in, and if you're a passenger or a pilot, you feel a kick in the back. It's such a big thrust, and it carries on down the runway at 247 miles an hour, much faster than a Formula One car. It lifts off and climbs away. As we're climbing away, we're going to put the lights off, and we're going to then get her more streamlined. We're going to take the nose up to 0 degrees. And then the heat shield visor goes up. So as she goes from London towards the Bristol Channel, she goes along at Mach 0.95, just under the speed of sound, so we don't get a sonic boom. But once she's out over the water, the engines go back to full power, and the reheat comes back on, and she climbs away. Concorde, this one flew at 63,000 feet. 20,000 feet or more above your Boeings and Airbuses. Once it is at about Mach 1.7 Mach, the reheat will switch off, and she continues to accelerate on engine power alone. And this is the fastest Concorde ever, Mach 2.2 times the speed of sound, 1,430 miles an hour, faster than a rifle bullet. The airline Concordes didn't run this fast. What the engineers found is the skin, the metal of the Concorde gets very hot at that speed, and so the airline ones run 100 miles an hour slower. As we're approaching the coast, 150 miles from the States coast, we have to start slowing down because it takes us 100 miles to slow down. 50 miles off the coast, we're just about subsonic, and we start heading in for New York. Now, as we're approaching New York, we start getting into the landing configuration, which is different from the takeoff configuration. First, we put the visor down. And then the nose goes down to the 5-degree taxi position. Excuse me, sir, you can't be in here. Right, now Concorde doesn't have flaps. It can't fly slow as an airliner can with its flaps down. So to go slow, it raises its head up, a bit like a duck or a swan coming to land, and it means the pilots can't see where they're going, even with the nose 5 degrees down. So this Concorde developed the nose droop to see how far down it needed to go to see the runway. And it has the droopiest nose of all of them, which Simon will show you now, or Glad, of 17.5 degrees. Now, like that, they can clearly see the runway at JFK, New York, to land. But when the airline pilots from Air France and British Airways started practicing on this Concorde, they were a bit concerned that the nose was completely out of sight, no point of reference. And so this one did a few different things and came up with the final position for the airline Concorde, which was a 12.5 degree droop. And so if you saw an Air France or a British Airways Concorde coming into land, this is what it would look like. Because we though have the droopiest nose, we're going to put ours back down to 17.5 degrees to land. And so we're in the landing configuration, we're heading in for New York Airport, we're going to put our lights back on so you can see us coming. And like that we land. We land much faster than the other airliners, 60 miles an hour or so faster than the other airliners, but we can also stop a lot quicker because we have some of the first carbon fibre brakes, and the brakes are also electrically fanned to pull them down. So we slow down to taxi speed and we're ready to pull off the runway onto the taxiway. So we're going to take the nose back up to the taxi position of 5 degrees. And like that, you can taxi off the runway to the terminal building. Once the air bridge is connected, so that our customers who paid a lot of money to fly on Concorde see her in her most sleek form, we're going to take the nose up to 0 degrees. And then that featured visor will come back up to complete the picture, and the guys will turn off the lights. And that's it folks, Concorde's demonstration. And the first flying display element is at